Hi students, we have started adding and subtracting with fractions. I want to go over a couple of examples so that you are familiar with what to do. We will start by doing an addition problem. Let's do a problem like 1/2 plus 3/11. And what we're going to do first is we're going to look to see if the denominators are like denominators. That means, are the denominators the same? And we said they are not. And we cannot add fractions unless their denominators are equal, because this is telling us how big the pieces are. So right now we're talking about different sized pieces. So we want to make them so it's the same, so we need to change it so we have the same denominator. So what I like to do is rewrite the fractions going down on my paper like this. And I'm going to set it up so I can figure out what new denominator am I going to choose. So I'm going to circle the denominators I have right now. I have 2 and 11. What we are finding is a common multiple of 2 and 11. A trick that I like to do is I look at the 11, I find the greater number, which in this case is 11, and I first ask myself, can 2 go into 11? No, 2 does not go into 11. So I say, okay, what's the next multiple of 11? The next multiple of 11 would be 11 times 2, 22. Can 2 go into 22? Yes, it can. So we just found a common denominator for 2 and 11. So I'm going to write 22 is my new denominator. This is the first number that both 2 and 11 share as a multiple. Now, I'm going to go back up to my first fraction, 1/2, and I'm going to think, what did I do to the 2 to make it become 22? Well, in order to make it become 22, I multiplied it by 11. So I'm going to have to do the same thing to the numerator to make this stay an equivalent fraction, a fraction that's worth the same amount. So I'm going to do 1 times 11, and that will give me 11 out of 22. Then down here for 3/11, I ask myself, what did I do to the 11 to make it become 22? I multiplied it by 2, so I will do the same to the numerator. And so my numerator will be 3 times 2, which is 6. So now, instead of adding 1/2 plus 3/11, I'm going to add the equivalent fractions of 11 22nds plus 6 22nds. So I'm going to rewrite my problem, 11 22nds plus 6 22nds. I'm going to add my numerators. 11 plus 6 is 17. And the denominator stays the same because this is just telling me what size of a piece are we talking about. So we'll keep it as 22nds. I'm not finished yet because I need to look at my fraction and think, do I need to simplify it? And in this case, I know the only factors for 17 are 17 and 1, and I cannot divide 22 by 17. So I have found my final answer. So this is how you can add with fractions. Let's try another one. And this time we will subtract with fractions. Let's say we have a problem that where they give us 3 numbers and they want us to subtract. So we could have something like 9/12 minus 1/4 minus 1/6. So first step, look at the denominators. They are not common denominators, so I have to change them so that all of the denominators will be like denominators. They will all be the same number. So I'm going to rewrite my fractions going down and think about what denominator can I use that will work for them. So I'm now dealing with 3 numbers, so this is a little bit trickier, and I need to find a number that's a common multiple for both 12, 4, and 6. So again, I'm going to start with my greatest denominator, which is 12, and I'm going to ask myself, can 4 go into 12? Yes, it can. Well, what about 6? Can 6 go into 12? Yes, it can. So in this case, I can just use 12 as my denominator. If 12 did not work, I'd have to try the next multiple of 12, which would be 12 times 2, 24. Now these also go into 24, but we'll go ahead and stick with 12 because that's the least common denominator. So I'm going to have 12 as my denominator for each fraction. I look up here, for 12 to become 12, we didn't have to do anything. It was like doing 12 times 1. So for the numerator, 9 times 1, it'll stay 9. For 1/4, we had to multiply 4 by 3 in order to get it to become 12, so we have to do the same thing to the numerator, and our answer is 3. And then down below, for 6 to become 12, we had to multiply it by 2, so we have to do the same thing to the numerator. 1 times 2 is 2. So now we have our new fractions, our new equivalent fractions that all have the same denominator. So now I'm going to rewrite the problem. It's really important when you're subtracting fractions that you make sure you keep it in the same order as the original problem. Because, as we know, we can add in any order, but we can't subtract in any order. So my first fraction was 9/12. My next fraction was 1/4, which we turned into 3/12. And then my last fraction was 1/6, which became 2/12. Now we can't subtract more than one number at a time. So what I'm going to do, put a box around this so it doesn't confuse us. What I'm going to do is first subtract the first two numbers. 9/12 minus 3/12 is 6/12. So now I have 6/12 minus 2/12. 6 minus 2 is 4, and we have 12ths. And now I think, can I simplify that? Well, the factors of 4 are 2 and 4. I can divide 12 by 2 or 4. I want to divide it by the greatest number that I could do for both of them. So since I can divide both of them by 4, I'm going to divide them both by 4. I'm going to write that down so I don't forget what I'm dividing by. And I end up with getting the fraction of 1/3. So our final answer for this problem is 1/3. So remember, when you're doing the problems, the first step is check your denominators. You want to create like denominators. Then your next step is to rewrite the problem. Once you solve it, then you have to think, can I simplify? If you follow those steps, then you should be in good shape. I know you can't see them very well on the board. Let's fix that. So there are the steps. Please also check your answer and see if it makes sense. Good luck!